Energy transition in the country is passing through the inflection point where not only governments but also all stakeholders are aligning to this transformation. Any energy transition cannot happen without improving the systemic efficiencies of distribution companies and empowerment of the consumers. And when we talk about systemic efficiency improvement of distribution companies in the country, the digitalization is the only move. It has been thoroughly realized now, and any digitalization can happen when we have the digital backbone, which would be formed by the smart meters. And probably government has realized this, and that's why government has come out with a massive mission program on smart metering in the country. IntelliSmart is trying to do and shoulder the responsibility to the extent it can. And in this drive, IntelliSmart has been launching innovation hackathons named Instinct. And this is the second wave of the Instinct, which has now been launched. And the last Instinct saw a massive response. This has encouraged us to make it even bigger, larger, and wider. The aim is to attract as many stakeholders from different communities and as many thoughts, as many ideas which can go into improvement of the distribution as a sector in terms of efficiencies. And team has come out with some of the beautiful challenges to be undertaken. I wish this to be a big success and look forward to big participation, great ideas which will go into forming digitalization as the key drive for our distribution sector and the country as a whole. Thank you.
Hello dear innovators, this is Anil Kumar Chaudhary, Chief General Manager and Head Operations in Energy Efficiency Services Limited. As already mentioned in problem statement, ESL is implementing the nationwide retrofitting of conventional street lights with energy efficient LED street lights and centralized control and monitoring systems CCMS to automatically control the installed LED lights and send real-time data of field condition to dashboard. Since we are concerned about interoperability of different makes of CCMS, let us now understand configuration of CCMS. CCMS is composite panel consisting of energy meter, contactor, MCB, power supply unit, you can call it AC to DC conversion unit also, CPU, and GSM or GPRS communication modem. Normally, items like power supply, AC to DC conversion unit, CPU and communication modem are built into one unit itself, generally called as RTU or remote terminal unit. Normally, the CPU is built using a microcontroller which is loaded with proprietary firmware. And here is the crux of all these issues. The communication module can be based on 2G, 4G, 5G or a dual unit. For example, a 4G model with fallback of 2G option. The power supply is either SMPS or capacitor based. Sometimes even energy meter is part of RTU. The typical diagram of configuration is being shown at the end. Now coming to the standardization of the hardware, the solution can be in form of standard electrical interface between RTU and other subsystems like contactor, MCB, energy meter. A common connector can be adopted in such a manner that at any time replacement of RTU even of different make may be done. The other parts like contactor, MCB, energy meters are generally interchangeable with different makes. The actual challenge is in standardization of the communication to and from the device. Communication is generally of parameters like CCMS ID, CCMS on-off, voltage, current, power factor, energy. All CCMS vendors are sending their data to their respective cloud server and the same is processed in their application server to depict in dashboard. If any command is given a dashboard, the same is communicated back to the same channel. IP address of each server is different for each vendor. Here it may be noted that if every individual CCMS vendor provide different set of parameter and the nomenclature are different. For example, even the voltage parameter, it is specified as V, VOL, VO. Many versions are used. Sequencing of data is also different. For example, it may be ID, on off, voltage, current, energy, power factor, or even reverse or jumbled by any other vendor. Also, data type may be different for vendor to vendor. Say integer, decimal, string, that too of different length in data itself. Hence, scores of variation is possible. Display pattern in dashboard is also different. Without inhibiting thought process of innovation, solution may emerge from designing uniform protocol for all the device for uplink and downlinks. All field devices may upload the data to a common IP address to be in centralized control. After common database, common dashboard format may be developed. Reverse communication from dashboard will follow the uniform protocol. One method may be development of interface of adapter APIs which shall bring in data to common structure. Feasibility of implementing solutions in already existing CCMS and dashboard is the key. This is what calls for innovative solutions. All the best.